Hi guys, in this video we are going to be looking at tectonic activities, tectonic processes and tectonic features, and this is for the GCSE Unit 1 and the first chapter of that unit, which is tectonic hazards. So I'm going to be going over the 4 plate margins today and talking you through the processes and the features. So if we look at the diagram that you've got in front of you, we see on the left hand side we'll start off with the constructive margins. Now constructive margins, as you can see from my red arrows, are where the 2 plates are moving apart from each other, they're being pushed apart. And this is also called a divergent plate margin. Now the mechanism of movement, obviously for all 4 of these margins, are convection currents within the mantle. That magma is heated by the radioactive decay in the core, that's the heat source, rises, gets up to the top of the lower crust, sticks to the asthenosphere, remember, and then drives the plates either apart or together or side by side. So that is the mechanism for all 4 of the plate movements. But if we just start here with the constructive plate margin, we can see that here with the margin is between 2 ocean crusts. So we've got ocean crust on both sides. The margin is in between, which leaves a relative gap for the magma to push up and be able to get out of. So the magma pushes up from the mantle, rises to the surface, normally underneath the sea, creates new ocean crust, and the plates are pushed apart just very, very slowly. So these 2 plates are moving further apart and this magma is pushing up and depositing lava on the ground, which is solidifying, and that's becoming new ocean crust. The other thing we have to think about here is that sometimes we can have a very, very strong convection current beneath the surface, and that will extrude lots and lots of lava, which will mean that we have a build-up of lava on the sea floor, which may well reach the surface and form an island, and Iceland is an example of this. So that is our constructive margin. Our next margin on the right here is our destructive margin, which is also called a convergent margin because, as you can see from the 2 red arrows, the 2 plates are moving together. So what we've got here at this margin is we've got ocean crust and continental crust. Now if we remember ocean crust, the characteristics are that it's very thin, it's very heavy and it's very dense. So it gets pushed underneath or subducted underneath the continental crust, which is thicker, more buoyant and lighter, relatively lighter. So that stays up and the ocean crust dives beneath it. So what happens is the ocean crust gets pushed beneath and it goes back into the mantle and it starts to melt. Now, due to the increase in pressure and friction here, it means that the magma, the melted crust, becomes lighter than the surrounding rock because it's hotter and it starts to rise up through the crust and through the continental crust, and it extrudes at the surface as a volcano. Now, we also get earthquakes occurring here, and as you can see, as the ocean crust dives beneath the continental crust, we have a little red circle, which corresponds to the idea that we've got a pressure and friction increase. So pressure and friction build, that crust will kind of snag or get stuck as it's pushing down. Over time, it will jolt forward, and that jolt forward will provide energy, which will be released, and that will be the earthquake. So this is a very destructive zone. We have very destructive earthquakes here and very destructive volcanic activity. We tend to have very explosive activity here, and we also have composite volcanoes because if we think about it, the magma here is kind of quite contaminated. It's not just magma from the mantle, which it is here. So this magma is highly explosive and we tend to get composite volcanoes formed, because the lava tends to be very sticky. Now, back to our constructive margin, the lava tends to be not sticky, non-viscous, so it spreads out. So we get shield volcanoes. So this is a link as well to a shield volcano, composite volcano. And they are these first two margins. Underneath now we've got a collision zone, which is actually also a destructive margin because the 2 plates are being destroyed. It's also a convergent margin because, as you can see, the 2 plates are pushing towards each other. But here the difference is we've got continent and continent colliding. So because the characteristics of both are that they are both buoyant and thick, neither of them are subducted, they're both pushed up. So we end up with a feature called a fold mountain. We also end up with pressure through at the margin between these 2 plates. So we will end up with earthquake zones, either deep focus or more shallow focus. And these again can be very, very destructive margins. You don't get volcanic activity here, but you do get earthquake activity here. And they tend to be very destructive earthquakes because of the amount of pressure that will build up. And therefore, once the pressure is released, that's released in the form of waves that cause, huge amounts of devastation around the world. So the example here will be the Himalayas, as India's pushing into the Eurasian continent, and the Himalayas are formed. The Himalayas are the fold mountains, and we get lots and lots of earthquake zones here as well as the two plates push together. So that is our collision zone. And finally, we've got our conservative plate margin, which, as you can see, the two plates are moving in parallel to each other, so they're moving in opposite directions, or, as is the case in San Francisco, they could be moving in the same direction but at different speeds. So what we can see here is that the plate margin is uneven. This means that at some points there will be a snagging, or it will catch, or it will stop, it will get jarred, and the plates will continue to push against each other. It will build up pressure, and then suddenly at some point those two plates will move past each other, and that is where our energy is released and we get our earthquake. So again, this is a very, very active zone. The conservative zone is very active, and it produces very, very, very destructive earthquakes. So the top two plates is where we get volcanic activity, the constructive and the destructive margins, and the two bottom plates, the collision zone, the conservative, we tend to get earthquakes and no volcanic activity. But these three, obviously you can see we get earthquake activity at these three. So they are our four margins, which you'll need to make sure you know for those exams for Unit 1. You'll need to know the processes, and you'll need to know the features as well.